Hello everyone, today we are going to implement a save load function for this adventure game we are working on. So I have created a checkpoint here. This is a checkpoint, and if player cross this area, cross this collider, the game will be saved at this point, and in the next time when I load the game will be starting from here instead of this default starting location. So at the moment I don't have I haven't saved the game previously. Let me open the door, and now when I go here we get the notification game saved. So if I go to the project saved, save games folder, we can see save data.sav, the save file is created. The location will be different when you package the game. Now let me stop the game. So if I play the game again, now we are starting from this position where we last saved the game. Okay, so that's what I'm going to work on today. Also I'm going to add this simple door as well, which can only be opened from this side. Once the player cross the door, he will not be able to open it again from this side. In that way we can block enter in the player once he cross this area, and the game is saved. And this episode is sponsored by this generous patron. Thank you very much for your support. Right, so next what I'm gonna do is, so here this is a door. Okay, so we will be able to open this door. Oh wait, there should be an opening, but yeah, no issue, we can implement it. So let's implement a door here, and then add a corridor here and another room here. So when we enter this room, let's make a save point. So here there should be another room, so and like a checkpoint. So the game will be saved in that checkpoint, and next time when I open the game should open from this last saved checkpoint. That means this room. So we can put sub levels if we want for each room, and load and unload objects based on sub levels. Okay, so first let me quickly create a door here. Now we can open the door like this, and similar to the way that we have implemented this collectible items or interactable items. Let me open one of the interactable item. So even though the door is not an item that I can collect, I can implement a door by extending this BP interactable. So yeah, let's do it like that. Interactable, create child, I'll call it BP door. Okay, and then let me place it here. So this can be changed to this 1 meter cube chamfer, this mesh. So I'll use that mesh, and the scale should be similar to this door scale. Let me copy the scale as well and paste it here. Alright, now we have a door. Location, let me copy that and delete it. Set the location. Okay, now we have this door. Oh, wait. Wrong. I edited this one. Sorry about that. I should edit this pp dot. Alright, now the objects are fine. Finally, copy the location and delete it. Set the location. Alright. So now when my character go near that, I should get, oh, I have collisions is not there. Okay, so let's add collisions. Also, I'll make it interactable by default. Can interact. No item, no need to have an item. So we don't need any of these inventory items. And we have this collider. I'll put it, I need this door to be opened only from this side. So when player cross, the player should not be able to open the door again. So to support that, actually here I can move this sphere to this side. Right, and then what's the message I get? Set interactable. Where do I get a message? I should get some message. Press. Here we have show tip. Okay, so here we get, usually for the collectible items we get the message and get the item name, use E to interact, but we need to override this function. So let me copy this part and show tip. I'll override it here. Press E to open. We don't need this. Okay, timeout. I think only 3 seconds would suffice, would be enough. Still I forgot to enable collisions. Select the object. Collisions, let's set to default. I think by default it blocks all the collisions. And then we need to override this function as well when the start interaction function. So when we press that, the door should open. So let me copy that. Let's just open it without doing anything else. this check, interacting check. So what we have to do is open the door. So that means by default the door is here, the mesh is in 0 0 location. If I move it to -169, let's say -170, the door will open. So get the object mesh, move component to, keep everything same, this one -1670, rotation and everything is 0. Over time, let's say 0.8 seconds, with ease in, ease out. And the door should automatically close after a couple of seconds, let's say 5 seconds. So we have to repeat the same thing. Move back to 0 and reset. Okay, now let's see. Okay, to open, I can move. It should close. Alright, it close. And when I go here, I can't open again. I'm locked in this side. Okay, just like this, let's have another room. This one has some Z5T. Okay, here is the other room. So once I get in here, I need to save the game in that place. So at the moment the game starts from here. Okay, now so how to implement saving the game? I think let's create a blueprint. In the type vector, call it checkpoint. Okay, so definitely we need a collider. Say box collision for the checkpoint. Let's place one here. Collision is not large enough. Okay, alright, now here when player overlap with this box, I'll make a save game. So to do that, let's get on component begin overlap. This one must generate overlap events, and we already have implemented player this interface function in the BPI character interface. So if this is true, that means player is overlapping with this box. Then we can make a save game. But where should we implement the save game function? Because if we save the game, we need to load the game as well, and when we do that, we need to know which checkpoint that I have saved last time. So for now, let's define another save game object. I'll call it save data. So here we need couple of things. First one would be player transform. So this is the player location and rotation. When the basically we don't really need the transform scale, but it's okay. So basically when the game is saved, this would be the player's location and rotation scale. I'm not worried about that. So and the next time when I load the game, player should start from this saved point. Also we have to implement stuff that save the items in the player inventory and load them when we start the game back. But first let's implement the player loading from the last saved location. Okay, so the checkpoint, I think we would need another blueprint that handles the saving and loading. Yeah, so here I'll create a new blueprint, and the type of factor I'll call it level manager. Okay, and I'll put one of these also in the level. This just have to exist there, and in the checkpoint, no, in the level manager, I'll add a variable checkpoints. Should be in the type of checkpoint. I'll turn this into an array and make it public, so we can add items here. Checkpoint, I only have one checkpoint, so I'll assign it. And in the checkpoint, I'll add a variable level manager and the type of level manager. and from the level manager in the begin play, I'll get all the checkpoints. For each, I'll set level manager variable with a reference to this self. Right, now if it is player, let's get a reference to level manager and call save. Oh, we haven't implemented that yet, so let's implement a custom event. Save game. Here we might need a reference to the checkpoint which calls save it. So checkpoint. Okay, so here now we can create a save file. So I'll create a variable, not an array, just a single variable using the type save data. Here we can initialize this. Get save data. We can check if it is valid. If not, we can create save game object using save data type. Then set it as save data. If we already have a valid reference, we don't have to do anything. We just have to get save data, set the transform, and as the player transform we can get a character, get transform, actor transform, and then save game to slot. I'll just call it save data and compile. Okay, now from the checkpoint I'll call save game. As the checkpoint I'll give a reference to self. We might not need this at this point, but we will need it later. Okay. Right. Now there should be a save game file created if it works, and it will be created in the saved folder. Let's see. Here we have save data, so that means save game is created. And also it would be better if we get some notification that says game saved. We can do that with this short tip that I have implemented in HUD. Get player controller, get HUD, active. Game saved. Only 2 seconds would be enough, I think. Okay, game saved. Alright, next part is loading, and that can also do in the level manager. After this part is done, let me collapse this. Init check coordinates. So now we can do does save game exist. Slot name I have used here is save data. Let me copy that from auto variable so that I won't have any differences. The branch, if true, we can load game from slot using the same slot name, and cast to save data, because we can only work with save data because we are saving our game data into the save data type that we have defined here. From the save data, now I can save this save data I just read from the disk into this variable like this. After that we can do the load game part, but at the moment all we have is just the transform when the game was saved in this player transform variable. So I'll just access it from here, get player transform, and set player characters location. Get player character, set actor location and rotation. Let me split this. Okay. Now see, game starts from here. So if I delete this save file, game will be starting from this point. Now the game is saved here. If I stop the game and play, now the game starts from here. See? So that's what happens. So the game is saved and game is loaded. So nothing in this inventory or quick access menu is saved at the moment. We will see how to do that in the next episode. And as always, project files will be available for the download in Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.